All right, boys and girls, this is Math Message 5-8, the main math lesson of the day, and we're going to work to find the missing factors. And we're also going to learn how to play multiplication salute. Before we get started, let's get our math brains warmed up. Get out paper and pencil or a whiteboard, and let's get ready. I am going to show you some division problems, and I want you to write the answer as quickly as you can. All right, let's look at these two problems. Now, you might have known the answer to these right away, 15 divided by 5. You might know what that is, or maybe you need to think about it in terms of multiplication. So if I turn that around, I could think 5 times what equals 15. So I could create that as more of a missing factor problem, right? 5 times what equals 15? 5 times 3 equals 15. A lot of times when I do division, I think of it in terms of multiplication because multiplication seems to be a little bit easier to do, and I can usually find the answer. So looking down at 18 divided by 2, if I say 2 times what equals 18, I know that 2 times 9 equals 18, so 18 divided by 2 equals 9. All right, let's look at the next one. I'll give you the next two here. See if you can work those out. Remember, you can always pause the video. All right, so now looking at 35 divided by 5. What could I think of in terms of multiplication to help me solve this division problem? 5 times what equals 35? If I count by fives, I know that 5 times 7 equals 35. And this one should be really easy. 80 divided by 10, well, 10 times what equals 80? And I know that 10 times 8 equals 80. All right, let me show you the next two problems. Go ahead and pause the video and figure these problems out. Okay, so let's turn this around to multiplication. I know that 9 times what equals 45. This one might be a little bit harder to think about if you don't know what it is. So you could skip count by nines. You could think of our nines trick that we did a couple of days ago. Remember our nines trick? Take one off, make 9. What number would I take one off and get 4? 5, right? Also, the fact that it ends in a 5 is a pretty good clue too. So 9 times 5 is 45. And now this one, 7 times what equals 70? 7 times 10 equals 70. All right, so that little warm-up goes along with what we're going to be working on today, finding the missing factors. Now, I want you to remember what a factor is. Factors are those numbers that you multiply together to get your product. So let's just say I have 3 times 5 equals 15. The 3 and the 5 are my factors. The 15 is my product. And I really need you to remember those vocabulary words, factors and product. We use them a lot in 3rd grade. Well, and you're going to use them a lot all the way through school. All right, so let's look at some problems. All of these problems, I'm going to give you some word problems, and we're going to create a number model with a missing factor. Okay, so it says there are 6 teams on the field for a tournament. Let's see, my thing is in the way there. There are 54 players in all. Each team has the same number of players. So how many players are on the team? So if I know that there's 54 players in all, I know that each team, there are 6 teams. So even if I kind of started to draw my picture, there are 6 teams. It says there are 54 players in all. 54 players, okay? If each team has the same number of players, how many players are on each team? So I know that each team has the same number, I just don't know what that is. How could we create a multiplication number model to fit this problem? Go ahead and pause the video and see what you come up with. All right, so I know that I have 6 groups of something. I don't know what's in those groups, but it equals 54. So that is my missing factor number model. 6 times something equals 54. Okay, really I was taking those 54 players, and dividing them between 6 teams, and I need to find out how many players are on each team. Or I could think of it as a missing factor problem, turn that around to multiplication, and think 6 times what equals 54. Pause the video and see if you can come up with the answer. All right, and you should have come up with the answer of 9. I was going to erase that, but I couldn't find my eraser. 6 times 9 equals 54. All right, let's do another problem. This one says a gardener picked 72 total tomatoes from his garden. Each tomato plant grows 8 tomatoes. So how many tomato plants are there in all? All right, so let's look at this problem a little closer. I'm going to pull that down so we can see that a little bit better. All right, so a gardener picked 72 total tomato plants from his garden. Excuse me. It says each tomato plant grows 8 tomatoes. So I'm going to think of this tomato plant, and I know it grows 8 tomatoes. How many tomato plants are there in all? So I have to figure out how many of these, I don't know, how many of these it's going to take to equal 72. Okay? So basically I'm taking 72 plants, I'm dividing them into groups of 8. How many groups will it take to make that 72? All right, so here's what I want you to do. I want you to turn this in to a missing factor number model and solve it. Pause the video. All right, so when I turn this around to a multiplication problem, I'm going to have 8 times something equals 72. Or it doesn't matter if you wanted to turn it around because you don't know how many groups. I don't know how many blank groups of 8 equals 72. So either way. And now what times 8 equals 72? And you should have 9 times 8 equals 72. All right, let's look at another problem. The math teacher split the class into 3 groups. There are 21 students in total. How many will each group have? So let's start drawing a picture of what we're doing here. Go ahead and pause the video. I want to see if you can come up with a good picture that matches this problem. The math teacher split the class into 3 groups. There are 21 students in total. How many will be in each group? Boys and girls, I want to see a picture. Okay, and I want to see a missing factor number model, and I want to see your solution. Go ahead and pause the video. All right, so when I draw a picture, because I know there are 3 groups, I'm simply going to draw my 3 groups. Now it says there are 21 students in total, so I know all together that's going to be 21. How many will be in each group? That's my question mark. What is the number model that would go with that problem? This is technically a division number model because I have 21 students. I'm dividing those 21 students into 3 groups. I'm trying to figure out how many is in each group. But I want you to turn that into a multiplication number model that's going to help you solve that easier. So you should have 3 groups of what equals 21. So now you have to figure out 3 times what equals 21. If you don't already have the answer, pause the video. And the answer is 7. 3 times 7 equals 21. Whoops. All right, the next one, it says Mrs. Jones made 42 cookies for her class. Each row had 7 cookies in them. How many rows did she make? Go ahead, I want to see your picture, and I want you to write a number model. Go ahead and pause the video. All right, so if Mrs. Jones made 42 cookies for her class, each row had 7 cookies. So I have a row here, and I know it has 7 cookies on it. Now, I could draw 7 tally marks or 7 circles, but I'm going to be a little bit lazy about it. I'm just going to go ahead and draw that row and write a 7. Now, how many rows did she make? She had to keep making rows, and I don't know how many rows, but all together, it was going to have to equal 42 cookies. Okay, so boys and girls, I'm taking those 42 cookies and I'm dividing them into rows of 7. How many rows will that be? Let's turn that around to a multiplication number model with a missing factor. If you didn't already do that, pause the video. And I should have 7 times blank equals 42. When I solve that problem, 7 times 6 equals 42. It would have taken 6 rows of 7 to equal that 42. All right, the next one, the chef made 27 meatballs. It says that each person gets 3 meatballs. At the end of the night, there were no more meatballs. So how many people ordered the meatballs? Let's go ahead and draw a picture and write a missing factor number model to go with this problem. The chef made 27 meatballs. Each person gets 3. At the end of the night, there were no more meatballs. How many people ordered meatballs? Go ahead and pause the video. All right, so when I start drawing what I know there are 27 meatballs. Okay, so in this big old pot, there are 27 meatballs, right? Each person gets 3. So I'm going to draw a person, and they get 3. Now, at the end of the night, there's no more meatballs left, so how many people ordered the meatballs? I got to figure out how many times I need to write 3, 3, 3, how many times to get to 27. So 3 times what equals 27? Because really what you were doing was taking 27 meatballs and dividing them into groups of 3, and you want to know how many groups there are. Pause the video if you do not have the answer yet and see if you can figure that out. And your answer should be 9. 3 times 9 equals 27. And 27 divided by 3 equals 9. All right, and the last one we have. It says 7 students were making bracelets. They wanted them to look the same and have the same number of beads. The students counted the beads and found that they have 56 in total. So how many beads can each student use if they want all the bracelets to look the same? So let's think about what's going on in this problem. I have 56 beads total. Now I'm taking those beads and I'm going to make necklaces, and I want them to all look the same. So this is going to be an equal groups problem, right? It says, so now I need to figure out, do I know how many is in each bracelet, or do I know how many bracelets I'm making? It wants to know how many beads can each student use. Oh, here it is. It wasn't in a number format, so I couldn't find it. 7 students were making bracelets. So I have 7 students. 1, 2, 3, 4, 5, 6, 7. Now I don't know how many beads, but I know that they're all going to get the same amount. Okay, so write a multiplication number model to match this problem. Go ahead and pause the video. All right, I was taking 56 beads and I was dividing it between 7 students. I'm trying to find how many beads each student will get. When I turn that around to a multiplication number model, I know that 7 times what equals 56. If you have not figured out the answer to this, pause the video and see if you can find the answer. Your answer should be 8. 7 times 8 equals 56. All right, so these are some missing factor problems. Missing factors is when you're creating a multiplication problem and one of your factors is missing. This is a great way to help you solve division problems. All right, now to learn how to play, before I teach you how to play the game, if you have fact triangles, these are great to help you practice missing factors. It's also great to help you practice division problems. If you have some fact triangles, you could cover up one of the corners. Let's see, I covered this up with my thumb, and then I think 8 divided by 4 is what? Or I could think what times 4 equals 8. So fact triangles are a great way to practice your multiplication and division facts. And now to learn how to play the game Multiplication Salute. Okay, Multiplication Salute is a lot like Addition Salute that you played in first and second grade, except this time you're playing it with multiplication. And so here's how you're going to play this game. Now here are the directions. What you need is some number cards. You need number cards 1 through 6 and the number 10 if you have it, and you need 4 of each. Now if you don't have number cards at home, you could make number cards or just using a deck of cards. Taking those regular old deck of cards that has the kings, queens, and kings. Just take out all of those kings and queens and jacks and just use the number cards. Use your ace for your number 1 and just use the cards 1 through 1 through 10 in a regular deck of cards. Okay, so a regular old deck of cards will work fine. Ideally, playing with 3 players is how this game is written to be played, but I know sometimes you don't have 3 players at home. I know at home when I play with my daughter, it's just her and I playing the game, so we have to adapt it a little bit, and I'll show you how to adapt it when you only have 2 players. And even in class sometimes we can't make 3 groups all equal, 3 people in a group equally in class. So sometimes we have to figure out how to play that. All right, so when you're playing the game, you're practicing multiplication and division facts, and you're trying to solve for a missing factor. Now, we know that factors are numbers you multiply together in a multiplication problem, but you're always going to have a missing factor. You've got to figure out what that missing factor is. So one person deals, or one person is going to be like the dealer. And the dealer gives 1 card to each of the other 2 players. Okay, so kind of picture this. You've got 3 players here, and 1 player is going to be the dealer. Now that dealer is going to deal a card to each of these players, but you're not allowed to see what the card is. All right, sorry, I had to pause the video for just a quick second, so I'm not sure exactly where I left off, but that dealer is going to deal cards to the other 2 players. Now, those other 2 players, they're going to immediately put the card on their forehead facing out, okay? You're not allowed to see your own card, so you have to have the card on your forehead, and you're not allowed to look at it. Now, you are allowed to look at the other person's card. Okay, so let's just say, for pretend here, let's say that the dealer gave this person a 4 and gave this person a 5. Okay, now this person isn't allowed to see their card, but they can see the 4. And this person isn't allowed to see their card, but they can see the 5. Now the dealer gets to see both cards. Okay, so the dealer is going to multiply those 2 numbers together. So the dealer is going to think in their head, 4 times 5, they're going to figure out that's 20, and the dealer is going to say 20. Now you have to figure out what's on your forehead. You can see the other card, but you can't see yours. You have to figure out what's on your head. Okay, so if I can see the 5, I'm going to think, okay, 5 times what equals 4? And the other person, they can see the 4. They got to think, 4 times what equals 5? Okay, so you kind of see how that gets played? All right, so now, what if you only have 2 players? And this happens at us at home all the time. So now we've got 2 players. So here's what happens. When I'm the dealer, I turn over a card that my daughter can see. So I might turn over, again, maybe a 4. And then I have another card that I can see, but she can't. Okay? And so again, maybe that's a 5. Now I think 4 times 5 is 20, so I say 20. Now, my daughter can see the 4, but she doesn't know what I have hidden in my hand. So she has to guess what's hidden in my hand. Okay, so the purpose of the game is for you to not see one of the factors. So if you're playing with 3 people, then one person's always the dealer. They can see both cards. They're doing the multiplying. The other 2 people, they can see what their partner has or what their neighbor has, but not what they have. You're always wanting to see one card and not the other card. If you're playing with just 2 players, you just got to be a little creative that way, where the dealer hides the card, you get to see one of the cards. There's always that missing factor. This is a really fun game to play. You can try to do it as quickly as possible. And the person who gets the most guesses the correct factor, gets to keep the card, and that's the way you can keep score. So if you guess it correctly, you get to keep it. If you're playing with 3 people, it's who guesses it the fastest, and that person gets to keep it. Okay, but it's practicing finding the missing factors, which really is practicing division. Okay, it's just an easier way to practice division. Kind of like we use addition to help us solve subtraction, we use multiplication to help us solve division. All right, ladies and gentlemen, that is it for lesson 5-8.